All right, welcome to the first video of Chapter 8. We are in Section 8.1. So we're now moving on from Chapter 7, and we are going to be looking at series and sequences in this section. So first thing we're going to focus on is being able to write out the first terms of a pattern or a series. You're going to see that a series and sequences are just lists of numbers, ordered lists of numbers. So they're not random, they're lists of numbers that have some sort of rule or pattern. Now by the end of the section you're going to learn how to identify the pattern of the lists. But what we're going to start out with first is writing out the first 6 terms. Now what I want to point out first, here's one of your core concepts. You're going to see that, like I just said, a sequence is an ordered list of numbers. Now, a finite series is a finite sequence. It's a function that has a limited number of terms. An infinite sequence is a function that continues without ever stopping. Now, you can use specific equations or rules for your sequences. For example, if you look at both these sequences and series right here, 2, 4, 6, 8, and notice the infinite one has the ... that means that it's going on forever. These are just even numbers. So what we do is it's identified, we use A, then the subscript n, which the subscript n just means that's our input, that's our variable that is being put in to determine the next value, is just described by 2 times n. So it's just 2 times 1, 2 times 2, 2 times 3, and so on. So let's go back to the problem. We want to write out the first 6 terms of this sequence. Now you'll notice right here, A means that that's our term value. N means that that's that number, that term number in our list of series. So for example, when n equals 1, that's our first term. When n equals 2, that's our second term. When n equals 3, that's our third term, and so forth. And here's our rule right here. So to find the first 6 terms, all you do is you insert 1 for n, that's our first term. So 1 for n gives us our first term. So again, A sub n means that when n equals 1, our first term is 1. So 2 times 1 plus 5 is just 7. To figure out our second term, we just plug 2 in. 2 times 2 plus 5 is 9. Our third term, we continue on. Third term, plug in 3 for n. 2 times 3 is 6, plus 5 is 11. And we just continue this. So you'll see these are all our values for the first 6 terms. Now if you look back at our pattern right here, 2n plus 5, the way you read this is when n equals 1, our first term is 7. When n equals 2, our second term is 9. n equals 3, third term is 11. n equals 4, fourth term 13. n equals 5, fifth term is 15. n equals 6, sixth term is 17. So that's how you do that for a pattern, for your sequence. Now that means for this sequence, if you wanted to figure out the 100th term, you would just plug in 100 for n, and whatever output you got, that would be the 100th term. So it's nice when you have this pattern because you know you can figure out any term in your sequence. Because this rule applies to an entire sequence of numbers, as long as you know n and you know your rule, you can figure out any term at any place in this sequence. Now, n doesn't always have to be a number that you're multiplying by in your pattern or your term. You'll see in our second series right here, we have our rule is -3 to the n minus 1 power. So this is your rule and you have to use it to determine all of your values. And you'll notice here n is in your exponent. So n can appear anywhere in your pattern or your rule, and you just have to, as long as you're evaluating this rule correctly, you can figure out all of your terms. So let's just go through this process again. I'm not going to go slowly, giving you all the terms. You can pause it and work out the math if you need to. So for the first term, you just plug 1 in for n, and you get 1 minus 1 is 0. So negative 3 to the 0 power is 1. When n equals 2, 2 minus 1 is 1. Negative 3 to the first power, negative 3. And we can go here and see the next 6 terms. So here, notice because n is in your exponent and exponential functions rise quickly, look what's happening to your values here. And also notice your exponents, because you've got this negative 3 here, your values are alternating between positive and negatives because you're taking a negative number to an exponent. All right, so that's finding the terms in a sequence. Now, what I want to do here is give you 2 problems to do. What I want you to do for A and B, you've got 2 rules, and I want you to do exactly what we just did. I want you to write the 6 terms, first 6 terms of each sequence. So in the answer box, I want you to label A and then write the first 6 terms, and then B, write the first 6 terms. Okay, and this is going to be your question for this example.